Hi. In this video I'm going to show you how to factor out the greatest common factor when you have a polynomial like this. So the greatest common factor, which we often refer to as the GCF for short, is going to be the largest thing we can divide out of all of these terms evenly. So we want to look at each of these terms part by part and see what we can divide out. I recommend looking at the numbers first. We have 15, 6, and 21, the coefficients. And if you look at those, the number that's going to divide all of those evenly, the largest one that's going to divide all of them evenly, is 3. 3 divides 15, 3 divides 6, 3 divides 21. Now, we're going to take a look variable by variable. For a variable to be part of the greatest common factor, it's got to be present in all of the terms. And you notice here, all of the terms have an x in them. In fact, all of them have exponents as well, so we have more than one x multiplied in. But since there is an x in every single term, we know x will be part of the greatest common factor. Now to know what exponent to use. Well, all we're going to do is look at the original problem and see what the smallest exponent for x is. We have a 2, a 3, and a 5. The smallest is 2, which means x squared will be part of our greatest common factor. So thus far we know our greatest common factor is 3x squared, but we're still missing one part. What about the y's? If we look here, you notice there is a y in every single term. Therefore, y shows up as part of the greatest common factor. As with x, we're just going to look and see what the smallest exponent is. And you notice here a couple of them, the one in the first term and the one in the last term here, have no exponent. But remember, that's just another way of saying that the exponent really is 1. That's the smallest number. 1 is smaller than 2. Therefore, that's what's going to be in our greatest common factor. Just that y to the first power, or y. That means this thing here, this expression, 3x squared y, can be divided nice and evenly out of every single one of these terms. And that's what we're going to do. We're going to rewrite them so that we sort of divide out that 3x squared y. First of all, let's take them term by term. And here, I'm just going to go around that and see what happens when we actually just rewrite it so that we're going to have something times 3x squared y for each of them. So we're going to go term by term and rewrite each part so it is something times 3x squared y. Let's start with our first one. Ultimately, we want it to be 15x squared y. We know we're sort of taking out this 3x squared y. So part by part, 15 divided by 3 will give me 5. Therefore, when we multiply these together, you'll notice my 5 times 3 will go back to the 15 I had up here. Next up for the x's, x squared divided by x squared, and it's going to take it all out so I have nothing left. For the y's, y divided by y simplifies completely, so nothing left. So if I take the original term, 15x squared y, and rewrite it to be 3x squared y times something, that something is just 5. Now we move on to the next term. Part by part, let's look at the number. Negative 6 is in the original, so we're going to rewrite that as 3 times something, so we're going to have negative 2. X cubed in the original needs to be x squared times something, so that will be x squared times x. And y squared in the original needs to be y times something. Y squared is y times y. So the original term, 6x cubed y squared, becomes minus 2xy times 3x squared y. Last one, we start with a 21, and we want 21 to be something times 3. So 21 is 7 times 3. Now for the x's. X to the 5th in the original is going to be something times x squared. Well, x to the 5th is x cubed times x squared. Next for the y's, Y in the original is what times y? Well, it's just 1 times y, so nothing to do there. The y's simplify out completely. So if you notice it the way we have it written here, we have all of the terms in the original one rewritten, so each has this product, 3x squared y in it. Therefore, 3x squared y is a factor in every single one. And we can go ahead and factor that amount out. So let me change my color back here. And I end up, if I take that part out of all of them, 3x squared y, factor it out, all I'm going to have left are these parts in front. So I'm literally removing the 3x squared y from each term and just writing down what is left. From the first one, I have just 5 left. The next one, minus 2xy. And the third one, plus 7x cubed. And that's what our answer is going to be. This is factoring out the greatest common factor. As you continue on, you can do this skipping quite a few of the steps. In fact, it's fairly easy after a little practice to skip all of these steps in the middle. You can skip all of this part right here and really focus on identifying first the greatest common factor and then just dividing that out of the original step by step. So if you see here, let me remove this stuff so it's a little easier to follow what I'm saying. You can always rewrite it just the way we did, doing it out step by step. Or, as I said with practice, you can start to skip all the middle and just jump from the original problem to the end. So when we do that, what we're really looking at is saying, okay, I know that my greatest common factor is 3x squared y. And what I'm going to do is take my original problem, term by term, and just divide out 3x squared y. So you notice I write my greatest common factor in front, and then in parentheses put what I get when I divide it out term by term by term. So my first one, 15x squared y, if we divide out 3x squared y, leaves me with just 5, which is where this 5 came from. Next up, minus 6x cubed y squared, I'm going to divide out a 3, which leaves me with negative 2. Divide out an x squared, which leaves me with just x, and divide out 1y, which leaves me with 1y left. For the last term, we have 21x to the 5th y, and I'm going to divide out 3, which leaves me 7, and divide out x squared, which takes my x to the 5th down to x cubed. And when I divide out the y, it goes away completely. And that's how I get my final answer. Either way, you get the answer you need.